Hello everyone, I'm the presenter of this paper. I'm YuanXing Chen, and my thesis topic is Distributed Cloud Monitoring Platform based on YuanXing. As shown on the PowerPoint, my presentation is divided into 5 parts. Due to personal reasons, I cannot attend the meeting on site. If you have any questions, please send me an email. My email address is at the bottom right corner of the last page of the PowerPoint. So let's go to the first part of our presentation, background. Most of the monitoring systems using Elasticsearch as data storage and the search engine directly use the YuanXing open source component. In the recent monitoring of a gateway system, we have implemented our monitoring function in this way. This way is easy to implement and its monitoring function is not weak. But we found the defects achieved in this way are also obvious. First of all, for many of the same data collection of the cluster, it's necessary to download and start the collector of one server one by one, which brings a vast workload. At the same time, the components of YuanXing are almost independent of each other, and the entire system cannot be managed uniformly. So we proposed and implemented distributed cloud monitoring platform. Image shows the architecture of the whole system, in which users interact with the front end of our system. Backend processing requests message from the front end. Data is collected through file bit and metric bit. Bitwatcher is a Go language-based self-developed service for managing file bit and metric bit. Meanwhile, Redis will be used to store user configuration data, and Flink will be used for data processing. Finally, the log data will be stored in ES for analysis and search. In designing the whole system, we divided the flow processing of log data into 4 parts. First, our platform provides node management capabilities. It mainly includes the following parts: one-click download and start, extract monitoring test data, transfer analysis configuration file, hold bit mechanism, data collector start and stop. Then it's data collection and parsing. Considering the diversity of monitoring data sources, we design our system to collect and easily parse log type data through file bit, collect metric types and data with standard template types via metric bit. Then we send data to the message queue for subsequent processing. The next part is data cleaning and processing. In our system, we will provide data processing capability through Flink. The data is read from the message queue, processed by Flink, and finally sent to the Elasticsearch for storage. The last part of the processing is analysis and visualization. The data layer implementation is shown in the picture. The data is generated by the server itself or by service running on it. Then the collection data is sent to Kafka through bit on the node. Flink consumes data from Kafka and streams it internally. The unstructured data is then transformed into structured data. The data is then streamed from Flink to ES for analysis and search. It is worth mentioning that both log collection, log distribution, log processing, and log analysis, the whole processing is manageable on our platform. Next is the system presentation section. Considering the time limit, we only show partial screenshots of our system. It includes machine management, collector management, log processing, log warehousing, log analysis, and real-time reporting. The last part is tests and results. The system consumes the most performance when performing an aggregate search on one log data. Therefore, what's shown here is the performance of the system in extreme cases when all requests are aggregated search requests. When the system node is 40 threads to access 4,000 and 8,000 times, the average response time is 51 milliseconds. When the system node is increased to 60 threads to access 6,000 and 12,000 times, the average response time is 99 milliseconds and 102 milliseconds. When the node is upgraded to 100 threads to access 10,000, 20,000, and 40,000 times, the average response time are 345 milliseconds, 360 milliseconds, and 364 milliseconds. Thank you for your patience. If you have any questions, please feel free to contact me through my email. You can see my email address in the lower right corner.